going to do today is we're going to study slope.
Yes.
Now, the nice thing about studying slope is that we have kind of already studied slope. I'll get into the slope thing a little too much. Okay, guys, remember what I said about, hey, we would be able to finish early if y'all didn't talk a lot and stuff? Well, this would be under that day. Y'all are kind of talking a lot today. So, let's listen. With y'all, it's kind of hard to teach every day. I mean, goodness. Okay. Okay, guys, so let's talk just in very vague terms about slope for a second. So, not specific. So, if we're looking at slope, there are 4 main kinds of slope. There are lines that look like this. And these have what we call a positive slope. Okay? Then we also have lines that look like that. And those ones have negative slope. Then we have lines like this. What kind of slope do those have?
Even.
0. Good job, Bryson. Those have a 0 slope. And then we get to the weirdest one of them all. No, not negative 0. It's a kind of good thought, though. But that. No. 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 It is a vertical line, but the slope here
is 1.
Alright, so we have undefined slope, which are vertical lines. We have a 0 slope, which are horizontal lines. We have positive slope. What makes it a positive slope?
It goes left to right. Wait, no,
Okay.
yeah.
Alright. It increases as you go left to right. Because you can't say, oh, it goes up. Well, you know, I mean, if you look at this one this way, it goes up too. But it goes up as you go left to right, which is the way that we normally read, right? When you read a book, you know, you look at the left and you look across to the right, okay? So, positive slopes increase. Your y value is increasing, right? The height is increasing as your x value is increasing. Whereas a negative slope, as your x value gets bigger, your y value gets smaller, right? So slope has to deal with what's happening to y as x changes. Cole, turn around. So what's our slope is how is y changing as x changes? Now, is there anything else that we've discussed this unit that talks about how y changes as x changes? Yeah, what is that, Will?
Rate of change.
All right, rate of change. Exactly. Guys, slope is rate of change. That's why I said I can probably teach this lesson pretty quickly, because really there's not a whole lot in this lesson that I haven't already taught. I just taught it as rate of change, and now we're just getting familiar with the concept of slope. Okay? So, the first thing you need to be able to do is from a graph, just very quickly pick out lines that go down as you go left to right are negative, lines that go up from left to right are positive, lines that go straight across are 0 slope, and lines that go straight up and down are undefined. Now, there's two ways that you need to be able to find slope from the homework tonight. Okay, two ways. So the first way we're going to find slope is we're going to look at 2 points. So let's say I have the point 5, -3, and I have the point -1, 0. And I want to find the slope. Well, slope is just the same thing as rate of change. It's how y changes as x changes. The other way that we define slope in this section is rise over run. You need to get familiar with that term. You'll hear your teachers across algebra say rise over run a lot. Slope is rise over run. Rise being how far it goes up, which is controlled by which coordinate?
The y.
The y, right? So rise is the difference between the bigger y value and the smaller y value. And then run would be
The x, how it goes horizontal.
right. How far it goes on the horizontal, which would be your x values. So this is generally how this is the equation for finding the slope of 2 points. You do the y value minus the y value and the x value minus the x value. Again, does that look familiar? Have we already done that? Yes, this is how we found rate of change from a table, right? You picked 2 points, you subtracted one y value minus the other y value, and then you subtracted the matching x value minus the other x value. So, it's funny, you're smiling an awful lot.
Very funny.
Brian. All right.
I am
So-
paying attention though because the y2 minus the y1, we've already done this before on the homework. I've been listening to you.
All right. So what is my y2 and which one's my y1?
The y2 is a higher y value, and y1 is a lower y value.
It can be. Really though, technically, it doesn't matter. You can do it in any order you like. So if you want to do 0 minus -3, or if you want to do -3 minus 0, either way is going to be the same. If I do 0 minus -3, then what's my x2 minus x1?
It's 5. Wait. 5 minus -1.
Nope. If I do 0 minus -3, then that means this is y2 and this is
3.
y1, which means this has to be x2 and that has to be x1. So it doesn't matter if I do 0 minus -3 or if I do -3 minus 0. But once I pick which one is going to be y2, then the value that matches with it has to be x2. Okay? So 0 minus -3 means on the bottom I'm going to have -1 minus 5. Now, guys, like I said, it doesn't matter though. If you had done -3 minus 0, then what would go on the bottom?
5 minus -1.
5 minus -1. Now, what is 0 minus -3?
-3.
What's 0 minus -3?
3.
Positive 3. Remember, minus and negative changes to plus, positive. Okay. What is -1 minus 5? -6. Again, minus, positive changes to plus and negative. So, 3 over -6. Now, over here, -3 minus 0 is?
-3
Okay.
over.
And then 5 minus -1 is 6. So here I get positive 3 divided by -6. Here I get -3 divided by positive 6.
Which will give you
And it's the same thing. Remember, guys, with a fraction, it doesn't matter whether the numerator is negative and the denominator is positive. or the numerator is positive and the denominator is negative. Either way, it's a division problem with opposite signs, so your answer is going to be negative. And 3/6 reduces to 1/2, so it will be negative 1/2. Either way you do it, the slope of this line is going to be negative 1/2.
With like the graphs, like I was looking at my homework, like with the graphs, they said you could like go over how many and then go up.
That we're about to go over that. All right, now, like I said, guys, that's one way that we can find slope is by looking at 2 points and subtracting the y value minus the y value over the x value minus the x value. Now, the second thing we can do is we can look at a graph and we can find slope from a graph. So let's look at an example. I'll tell you what, if you have your workbooks out, look at the 8.6 skills practice and we'll look at a couple of the examples on there. That way it'd be easy for you to make notes on it. Okay. Now, I can do this, without using the examples in the book, but this way it's easy for you to take notes because you already have the graph sitting in front of you. So, all right, so all right, so let's see. Do we want to do number 1? Sure, we'll do number 1. All right. All right. All right. So, guys, so number 1, we've got a line that looks something like this. Now, if I want to find the slope from a graph, could I still find 2 points and subtract the y value minus the y value and the x value minus the x value?
Yes.
Yes, I could. That's still an option. But if you remember that slope is rise over run, then a slightly faster way to do it if you're given a graph is that you can count. That's right. It's like y'all are back in like kindergarten doing counting here. Now, guys, you still need to pick 2 points. One is going to be, one is going to be where you begin and the other is going to be where you end. So let's say, for instance, that I pick that as my beginning point and I pick that as my ending point, right? Now, to find the slope, basically you're going to give directions, how to get from one to the other. But you're going to give the directions in terms of rise and run. How much do I need to rise to get from point A to point B?
1.
All I have to do is go up 1, right? So the rise of this is 1. Now, how many units do I need to move over? How many do I run to get from A to B?
3. So I can already do 1 through 6 on my board.
So, right. I rise 1, I run 4. So, the slope of this line, without having to find the 2 points and subtract the y value minus the y value and the x value.
Give you 2
Okay.
points on a graph.
Well, if they're on the graph, you can count. If it's not on a graph. Now, if they just give you 2 points, taking the time to sketch the graph really is not a good use of your time. Okay? But if you're already given a graph, it's easy to just count. So that would probably be my go-to option there. Also, shortly we're going to start learning how to graph if you're given the slope how to graph, so this is good practice getting you used to finding how to use slope to get from one point to another. So this has a rise of 1 and a run of 4. One thing that I always recommend as the first thing you do before you start is look at the slope. Remember, we have 4 types of slope, right? 4 types. Which kind is this?
Positive.
Did our slope come out to be positive?
No.
Okay, so we're good. Our slope is positive 1/4. Now, let's look at question number 5, because what's different about question number 5?
Negative slope.
It's a negative slope. So let's look at what it looks like if we have one with a negative slope.
Going left or down counts as negative instead of positive.
So for this one, I have, it's going to cross through this. Oops, don't do that. Stay. All right. So it's going to cross through that point, and it's going to cross through 4, 1, that point. So our line should look something like,
Wait, what number is it? Number 5?
yeah. So it should look something like this, all right?
I thought the other point was the one you're connecting it to. No,
Do what?
what's that one on the side?
Oh, that's where my hand touched the thing and made an accidental point. All right. So,
No,
okay. Yes, Cameron.
So say it was like an improper fraction, would you write it like a...
Improper. Leave it in improper fraction because slope is rise over run, and if you change it into a mixed number, what's the rise and what's the run? Okay, so you don't want slope, you always want to leave in fraction form. Don't make it. Now, well, I take that back. Unless it divides, now if it divides into a whole number, like if it comes out to be just plain 3, go ahead and write your slope as a whole number. Just know that 3 is the same thing as 3 over 1. But if it comes out to be improper and it'd make it into a mixed number, just leave it as an improper fraction.
Leave it as an improper fraction.
As-
If it's 5 over 1.
No, divide it out. If it comes out to be a whole number, it should either be a whole number or a fraction.
There are 2 like
Okay.
that.
Guys. Can we save questions? Let me get through this and then we'll see. All right. So for this one, again, I got to choose my point. So they say that one's point A and that one's point B. How much do I have to rise to get from point A to point B in this one?
-3.
Well, it's still described as rise. It's going to be a negative rise, right? Because I'm not going up, I'm coming down. So negative,
3.
nope, 1, 2. Okay?
Wait. Well, it doesn't say point A and point B on the homework.
I know, I was just labeling so you know which ones I'm looking at. Because, guys, do I have to use those 2 points? No, I can use any 2 points that are on the line. Okay? I just picked those 2 because those are the ones that most clearly the line went through at an exact. You do want to pick, like I don't want to pick, say, this point here because what's the value of that point? 5 something, but we don't know exactly what that something is. So you don't want to use that because it's not an exact value. But other than that, you can pick any point where you know the exact value of it. You can use those 2 and get your directions from those 2. So let's look at these 2 again. So from A to B, I'm going down 1, 2 units, and I'm going to the right 1, 2, 3, 4 units, right? So my rise is -2, my run is +4, which means my slope is -1/2. Does this have a negative slope?
Yes.
Yes. If we look from left to right, it is going down. I tell you to do that to double check because so often students will, look at it and they'll forget that they'll just look at, oh, it's a difference of 2. Like they'll go, oh, well, there's like 2 units between these, so they'll go, the rise is 2, and then they'll go, and that's 4, and they'll just count the distance without thinking about the direction, and then they'll give me their slope is positive when it's negative. So always double check and make sure that if it's a negative slope, that your answer is negative, and then if it's a positive slope, your answer is positive. Okay? Kaylee?
Do you always simplify the fraction?
Yes. Unless, again, if it's an improper fraction, don't make it a mixed number. Okay? Your answer should be a whole number or a simplified fraction. Okay? Now, the only other thing that I want to talk to you about is what does it look like if we have, now obviously from a graph it's really easy to pick out a zero slope or an undefined slope, right? I mean, if it's a zero slope, it's a horizontal line. If it's an undefined slope, it's a vertical. But what about if I have 2 points? So let's look at those examples. So let's say I have 4, -2, and 4, 5. If I go to find the slope between these 2 points, how would I do that? How would I find the slope between these 2 points? Josie?
Do 5 minus -2 over 4 minus 4.
So 5 minus -2 is 7. And 4 minus 4 is?
0.
And 7 divided by 0 is?
0.
All right, do me a favor. Pull out your calculator and type in 7 divided by 0.
Error.
All right. This
Oh, yeah, that's it.
Why wouldn't it be
This
zero?
is undefined. Now, guys, this is where we have an undefined slope. If the run is 0, then that means it's not going anywhere horizontally. It's only going up and down, which makes it a vertical line, which is undefined. Now, why is division by 0 undefined? Because think about it. Division is like putting things in groups, right? If I have 7 objects and I want to put them into group size 0, how many groups am I going to need to create in order to divide up all 7 objects?
None. So why wouldn't it just be 0 then?
Because when you're dividing something, you have to keep dividing until you don't have a remainder, right?
You have a
How-
remainder of 7.
You have a remainder of 7. If I keep dividing by, if I keep doing groups of 0, here's a group of 0, here's a group of 0, here's a group of 0. All right, so let's say I have 1, 2, 3, 4, 5, 6, 7. All right, let's say I have those 7 students, and I'm going to make groups of size 0. Well, here's a group of size 0. I got 1. Here's a group of size 0. Here's a group of size 0. And I can keep making those groups. And when am I going to end up putting them into a group?
Never.
Never. Okay? It's undefined because it doesn't make sense. You can't talk. You cannot, guys. You cannot talk about dividing something by 0 because even though I could make an infinite number of group size 0, I still wouldn't have divided them up, would I? Because they aren't in any of those infinite groups size 0 that I'm creating. So really I'm not grouping them, I'm just making non-existent groups of nothingness, and I'm still not actually dividing anything. So this is